There are 7 layers of Claude Code user and 90% of users belong to level 1, maybe level 2, and only 5% are actually using true potential of Claude Code. So let me break down each and every single layer with live examples so that you understand which layers you belong to and how you can level up the ladder. Level 0 means that you're just getting started with AI overall and you're using Claude AI ChatGPT as an AI coding assistant to help you with small tasks. Here you're just interacting with AI in a chat session and you're doing literally everything on your own, from copying and pasting code base to giving full context about your issues. So let's open our Claude AI chat session, and here I have given it the context that hey, I'm solving this particular lead code problem and here is my current code base. I know I'm talking about code here, but that is literally applicable to every other industry that you might belong to. For example, real estate, marketing, HR, and you are hand-holding AI with every single news session by giving us full context, copying, pasting data manually, and then going back and forth with multiple prompts until you're happy with your answers. Here I have to manually copy this data, go back to my IDE. In this example, I'm using VS Code and paste this data and do everything manually. That is very limited way for you to interact with AI because it does not have any access to your current code base, nor it can edit or read any of the current files. And that's why you move up to the next level, which is where you're actually setting up Claude Code with the default version. You don't have any extra configuration, you don't even have claude.md file or any of the skills. So you just open your code base, then you install Claude Code extension from here, click on install. Let's open our Claude Code session, and this is literally a default Claude Code session once you have set up for the first time with no extra configuration, no MCP servers or nothing like that. You have to manually edit all of your files. For example, let's open our code base. And let's imagine I am very well aware with this entire code base. So what I want to do is I want to change something. Let's say I want to change the font size or overall the body font of the entire code base. So I will say, can you help me? Let's copy this file path name, copy path, paste it here, from SF Pro, enter. And now from here it will actually start reading the file that we have given it to, which is our globals.css file. And as you can see, it is editing the file. The current font was SF Pro text and now it is enter. So you can see in our code base, it has changed to enter. But that said, you are still babysitting with each and every single step and it does not have any autonomy nor it has any context with the next session. So let's say we kill this session and start a new one. It will have no idea what we have done in our past session or what is this entire code base about. And that's where you move up to the next ladder, which is setting up your claude.md file or your memory management, so that you make sure that once you open another next session, it is not going to ask what this code base is about, what you are doing in this project and what it can help you with. Can you help me understand what we are doing in this project? Let's open our claude.md file, which is our memory file that is going to be loaded once you start a new session. And as you can see, it is actually taking a look inside our claude.md file and will give us an accurate picture of our whole code base. So what this project is about, what it is currently doing, which is overlays, carousels, repurpose studio, and multiple of other content creation helper tools. So here you can see you're not repeating the same thing over and over again like what this project is about. So I believe most of the people watching this video will be in this expertise level where they have set up then basic claude.md file, maybe some skills or MCP servers, and they have persistent memory in each and every session. This entire 7-step ladder is true for every other AI coding assistant, for example, Codex, Cursor, or anything that you're using. So if you're not using Claude Code, you might be using Codex and you have to set up agents.md file, which is similar to claude.md file. So let's open agents.md file, which is universal memory management file that will work with your Claude Code, Cursor, Codex, or any other AI coding tool that you are using. And as you can see, it is pretty well documented with dense informations, so it knows exactly what it needs to do in all the future sessions. But if you are at this level, it's time for you to move on to the next level where you're delegating tasks with your main agent, spawning sub agents having their own context window limit, so you're not populating or having hallucination in your main agent. Now let's ask you to conduct a deep research on what is the trending Instagram format that is working and deploy sub agents for research. Now what it will do is it will deploy sub agents. As you can see from here, we have our agent number 1 with having their own context window limit. So they will go out and do all the research and give you a main session, which is our main agent, and get that overall summary or research without your main session knowing each and every single step this sub-agent took. And that's how you are orchestrating a pseudo workflow where multiple sub-agents are spawning to complete the task or particular job your main sub-agent has spawned for it. And there you go, it is done with all of the 3 sub-agents, and these sub-agents are reporting to our main base agent. And here is the overall summary which our main agent will read, plus all of these sub-agents are working in parallel. So let's say you have 50 sub-agents working in parallel, so you are definitely going to save so much of the time, whereas just your main agent doing all of these 50 agent works one by one. And you can see it does not have to do any of this manual research on its own and overbloating our main agent context window limit and just reading this overall summary and finding of the sub-agents. And as you can see, each of these sub-agents took around 60,000 tokens. So it is around like 180 tokens it saved from our main session agent. Then comes our level 4, where you are the orchestrator of these multiple agents deploying their own agent team. Just to show you one example, this is my session number 1, session 2, session 3, and all of them are doing just one task, which is writing blog articles for my SaaS marketing. But the problem you can understand is you have to be the orchestrator managing all of these agents, and most developers are at this stage. Here you are manually reviewing your agents' work and what they are doing in each and every single session, which might become tedious and overcomplicated if you don't know what you are actually doing inside your code base or project. So it will still not matter if you deploy full agent teams, you are the one still orchestrating each and every single step your agents are taking. But now it's time for you to level up to delegate that orchestrator job to agent itself, where you have main orchestrator agent managing hundreds of agents having their own context window limit. So this is the level where you totally step out of the game and let agent have their full autonomy it deserves. Now, how you can delegate that orchestrator job to an agent itself? By using dynamic workflows inside Claude Code. So once you launch dynamic workflow, it has ability to spawn thousands of agents per session, each having their own context window limit divided into different phases. So let me just give you one simple example. So let's call dynamic workflow / dynamic workflow and select the effort level of extra high plus workflow. You will see a purple gradient in your prompt bar. Now let's give one example of niche competitor reel finding with dynamic workflows. So as you can see, it has spawned 4 different phases. First phase is scan, patterns, deep dive, and synthesize at the end. And all of these phases have their own sub-agents assigned to them with a model, which is in our example Opus 4.8, how much token they consume and how long it took for them to execute the job. So here we have these agents having their own sub-agents and our main orchestrator agent that is managing all of these 4 phases, reviewing and checking what they are generating and making sure that it actually aligns with whatever task or goal that we have defined at first. So by using dynamic workflows, you can spawn hundreds of sub-agents, each having their own context window limit and giving your agents true autonomy they deserve. But at the same time, your agents are going to consume much more tokens as they are doing everything on their own. To show you the consumption part that I was talking about, this one dynamic workflow run consume about 1 million token that is running on Claude Fable 5 that will cost me around $10 per one dynamic workflow run. But if you are getting the ROI positive with each and every single run, it will obviously make sense to keep running them on and on. And here all of these agents are working in worktree isolation so that they are not overlapping with each other output. Then definitely you have to set up strict guardrails before you even start executing your workflows, otherwise funny things will happen in your code base. And last but not least, we have fully autonomous mode where there is basically no need of human or developer needed. Here you are not prompting your Claude Code sessions. Instead, you are designing loops, and those loops are prompting your Claude Code. To show you what I mean about loops and full autonomy, this is a video clip of Claude Code creator talking about how he is using loops and he is not prompting Claude Code session anymore.
Wow. At that point, I was running, maybe 5-10 plots in parallel.
As he mentioned, he was using 5 to 10 Claude Code session in parallel, so he was talking about these levels. But now he has come to fully autonomous mode.
My coding was prompting Claude to write code. Now it's actually leveled up, I think, again, to the next layer of abstraction where I don't prompt Claude anymore. I have loops that are running. They're the ones that are prompting Claude and kind of figuring out what to do. My job is to write loops.
And this is the part you don't prompt your Claude Code session anymore. Instead, you design loops, and those loops are prompting your Claude Code session. Even the founder of OpenClaw, Peter Steinberg, also saying the same thing. Here is your monthly reminder that you shouldn't be prompting coding agents anymore. Instead, you should be designing loops that prompts your agent. Basically, what that means is you design a loop once. In our example, it will find for new GitHub issues. Now, once it will find any GitHub issue, let's say GitHub issue number 1, what it will do is it will prompt our Claude Code session. We are not prompting anything here. it will prompt our Claude Code session that, hey, first of all, can you read this issue? Then once it has full context about the issue, then our loop will send another prompt to our Claude Code session, hey, can you implement the fix? Then the third prompt, which is run the build and test until everything is green. Then our fourth prompt, can you open a PR? Fifth prompt, can you merge it? And sixth prompt, can you close the issue once done? So all of this 6 part and all of the prompting is done by the loop. You're not doing any kind of prompting here. You're just designing the loop once, and the loop will take care of prompting your agents. Let's head back to our Claude Code session and design this loop in real time. All you need to do is type /loops, and then there are basically 2 types of loops. The first is polling loop and the second is dynamic loop. Polling loop, as the name suggests, will have intervals that it will repeat after, let's say after 5 minutes, half an hour. So we want to create a loop that will check after every single 2 minutes that are there any new GitHub issue open or not. And the dynamic loops is like one-off thing. So for example, hey, you have this big task and make sure that you are involved in this entire prompting session with Claude until it is fixed or until it is completed. So let's create a loop for 2-minute interval and just define what we want our loop to do, which is check for new GitHub issues, and for each one read it, implement the fix, run and build until it is green, open the PR and merge and close once it is done. Now to trigger this loop, let's open a GitHub issue in our project, and it has caught our GitHub issue automatically in our session. So first of all, it is reading the issue, implementing the fix, verifying that, creating a PR and closing the issue, merging everything to main and deleting that branch. So here, whenever there will be new GitHub issue, it will automatically fix this on its own without you having to involve whatsoever. These are the 7-layer progression of any Claude Code user when they have just started by using Claude AI, and now they are sitting at the top where everything is fully autonomous by designing loops and launching dynamic workflows. To summarize, with each and every single layer progression, you are giving your agents more and more autonomy, and you are excluding yourself with less and less human in the loop. But if you are a complete Claude Code beginner and you don't know anything about this, or you might be at level 1 or level 2 and you want to go to these last levels, make sure to join our community. First link in the description, where we have everything breakdown step by step how we are giving agents true autonomy they deserve with zero human in the loop.